In today's lesson, we're going to talk about perpendicular vectors. Now let's begin. Now, two vectors are said to be perpendicular to each other when the angle between them is 90 degrees or when they meet at 90 degrees. So that means that the vectors AB and the vector AC, they are perpendicular to each other because they are meeting at 90 degrees. That's a 90-degree symbol. Now, one thing that you're supposed to know is that perpendicular vectors, they have a dot product of 0. And I'm going to show you why the dot product of perpendicular vectors is 0. This is the reason. Now, let's try and find the dot product of, the vector that we have here. And before we do that, you should know this one. Generally, the dot product of, two vectors, let's say A dot B, is given by the magnitude of A times the magnitude of B cos theta. That's the general formula that you're supposed to know whenever you want to find the dot product of, vector. Now, let's come to these two vectors, the vector AB and vector AC. So if you want to find the dot product of the vector AB and that of vector AC, that is what we are going to do. We have to find the magnitude of vector AB, then we multiply by the magnitude of vector AC, and now we multiply by the cosine of the angle between the two vectors. Now, in this case, the cosine of the angle is 90. So we are going to get the magnitude of vector AB times the magnitude of vector AC times cos 90 degrees. The reason is that the angle here is 90. You know that cos 90 is equal to 0. You can use a calculator to verify. So that means you're going to get the magnitude of AB, the vector AB, times the magnitude of vector AC times 0. And obviously, we are going to get 0. Yeah. So that should tell you that whenever you multiply, two vectors that are perpendicular to each other, you're supposed to get 0. You have to know this one. Now let's take some examples using this, property. So let's get our first question. Two sides of a triangle are represented by the vectors P. These are the components 2, 3, and the vector scale 3, -2. Show that they are perpendicular to each other. Good. So we want to know whether this triangle is a right angle triangle. Because the moment these two sides are perpendicular to each other, then it means that triangle is a right angle triangle. Now let's say something. This is the condition that you're supposed to know. P and Q are perpendicular if the dot product of P and Q is equal to 0. So after finding the dot product of P and Q and we get 0, then it means that the vectors P and Q are perpendicular to each other. Otherwise means they are not perpendicular. So let's begin. So we have P dot Q and we are supposed to get 0. So let's do the substitutions. So the vector P, it has components 2, 3, dot the vector Q also has components 3, -2. And we are supposed to get 0. Now, let's see how we are going to find the dot product of these two vectors. This is how we're going to do it. We just have to multiply, the corresponding components, then we add the products. We did a video on that. You can go and watch how to multiply vectors. So you're going to get something like this. 2 times 3 plus 3 times -2. And remember, we are supposed to get 0. Now, 2 times 3 is 6. Plus 3 times -2, we're going to get -6. And we're supposed to get 0. Now, let's say something. 6 plus -6 is the same as 6 minus 6. And now, we are supposed to get 0. Now, 6 minus 6 is 0. And 0 is equal to 0. So this is true. That means that the vectors P and Q are perpendicular to each other. So you can write that, therefore, P and Q are perpendicular. So that is it. Question. The vectors M has components. So let's say the vector M. So M has components 5 minus x plus 8, and N also has components 3, 2. And they are perpendicular. We have to find the value of x. So this time, they are saying that the vectors M and N are perpendicular. So the fact that they are perpendicular means that their dot products, that means m dot n should be equal to 0 because they are perpendicular. So this implies that 5 minus x plus 8 dot, 3, 2 should be equal to 0. Yeah, because they are perpendicular. Now what do we do next? We have to, multiply the vectors. So we're going to get 3 multiplying, 5 minus x plus 2 multiplying x plus 8. And we're supposed to get 0. Now, remember I did this because, these terms are, they are binomials. These expressions are binomials, so they have to be kept in brackets. So now 3 times 5, we're going to get 15. So we have 15, and 3 times negative x, we have negative 3x. Now, 2 times x, we're going to get 2x, and 2 times 8, we have 16, equal to 0. So this is what we're going to get. You have to collect like terms. 15 and 16, they are like terms, so they can be grouped. So 15 plus 16, negative 3x, and that of 2x, they are also like terms. So you have minus 3x plus 2x, and that is equal to 0. So at this point, we can simplify 15 plus 16, that's going to be 31. So minus 3x plus 2x, we're going to get minus x equal to 0. So what do? You know, we have to, do away with this, 31. So you have to subtract 31 from both sides. Or simply, we can take, negative x to the side so that we get x to be equal to 31. So I want to subtract 31 from both sides. So I'm going to get 31 minus 31, minus x equal to 0 minus 31. So 31 minus 31, we're going to 0. We're going to get 0. Now we are left with minus x equal to negative 31. So to find x, we just have to divide here by 1, here to by negative 1. So they will just cancel out. So the negative will cancel the negative. So we have x equal to 31. So that's the value of x. If the vector A has component 2, 4, and B has component K 5 are perpendicular, find the value of K. That's our next question. So now the vector A has component 2, 4, and that of B has component K 5. So the question is saying that they are perpendicular. So we have to find the value of K. So the fact that they are perpendicular means that, let me write it here. A dot B is equal to 0. So I'm going to use this, idea to find the value of K. So A dot B is equal to 0. And this implies that the vector A, which has component 2, 4, dot the vector, B, which has component K 5, should be equal to 0. Now this implies that we're going to multiply the two vectors. And this is how we multiply. We multiply the corresponding components, then we add the product. So you have 2 times K plus, 4 times 5, and we are supposed to get 0. 2 times K is 2K, plus 4 times 5 is 20, and it is equal to 0. So what do? We have to subtract 20 from both sides. So you have 2K minus 20, plus 20, equal to 0 minus 20. So we have these guys, they will just nullify each other. So you have 2K equal to negative 20, divide here by 2, here 2 by 2. So 2 here 1, 2 here 1, 2 here 1, 2 goes into this, negative 10. So that means that K is equal to negative 10. That is the answer. And that's the next question. So given that P dot Q, the product of P and Q is equal to 0. P has these components and then Q also has these components. We have to find the values of X, the value of X. So the condition has been stated already. We just have to do substitutions here to find the value of X. So now P has components of this. So we have 6, 2x plus 12 dot the vector Q also has components X, negative 1. And we are supposed to get 0. Now let's simplify the vectors by multiplying them. So you're going to get 6 times x So we have 6 times x plus, negative 1 multiplying, 2x plus 12. And we are supposed to get 0. So 6 times x is 6x. So we have 6x here. So negative 1 times 2x, we are going to get negative 2x. And negative 1 times 12, we have minus 12. And that is equal to, 0. So 6x minus 2x, we are going to get 4x. So we have 4x minus 12 equal to 0. So simply, we can add 12 to both sides so that we can do away with this negative 12. Or straightforward, if you want to do this, you can take negative 12 to this side. That one too can be applied here. So now I want to add 12 to both sides so that we get 4x minus 12 plus 12 equal to 0 plus 12. So this will imply that, 4x negative 12 plus 12 is going to be 0. So that is equal to 0 plus 12 is 12. So to find the value of x, simply we just divide here by 4, here 2 by 4. So 4 cancels itself, 4 goes into itself, 1 goes into 12 3 times. So x is equal to 3. So that is how we can find the value of x using the above information. Question. If the vectors p with component 7, 2 and q with component 4, 2, x plus 6 are perpendicular, we have to find the value of x. So the vectors p and q are perpendicular, and because of that, their dot product should be equal to 0. So p dot q is equal to 0. So this implies that the vector p has components, 7, 2 dot the vector q 4, 2x plus 6 is equal to 0. Now we have to, multiply the vectors. So we're going to get 7 times 4 plus 2 multiplying 2x plus 6. And we're supposed to get 0. Now, this implies that 7 times 4 is 28. And we have to expand this one to remove the bracket. 2 times 2x, we're going to get 4x. And plus 2 times 6 is 12. And that is equal to 0. So you can collect like terms here. 28 plus 12, they are like terms. And then plus 4x is equal to 0. So 28 plus 12 is going to be 40 plus 4x. And that is equal to 0. So simply, we subtract 40 from both sides. Or you can take 40 to the other side. So I'm going to subtract 40 from both sides. So that's going to be 40 minus 40 plus 4x equal to 0 minus 40. So 40 minus 40 is going to be 0. So that means these guys will be out. So now we have 4x equal to 0 minus 40 is negative 40. Divide here by 4, here 2 by 4. So 4 goes into itself one time, it goes here 1. Now we have to simplify this one too. 4 here 1, it goes into negative 40, negative 10. So that means x is equal to negative 10. So that's the value of x.